video, I'm going to be talking about how the data cycle part influences the CPU and how also the CPU fetches and executes instructions as a whole. The data cycle part is a critical influence on the CPU performance because it governs how efficiently data is moved and processed, and also returned between various components in the CPU and the memory. The length and complexity of the data cycle path directly affects the latency, that is the time it takes for data to travel through the CPU. The shorter and more optimized path reduce the delays and allows instructions to execute faster in the CPU. The CPUs execute multiple instructions per cycle in modern architectures. If the data cycle path is slow or congested, the throughput, that's the number of instructions processed in a second, will be limited or will lower the performance of the CPU. Also, instruction dependency. Many CPUs instructions are data dependent. If data from one stage of the cycle path is not available in time for the next instruction, the CPU will delay or stall, leading to the pipeline hazards like data hazards or control hazards. The cache and memory hierarchy. The design of the data cycle path impacts how data is accessed and moved within the cache memory hierarchy. Inefficient paths might result in frequent memory access delays, cache misses, significant slowing down of the CPU. All this means that the data cycle path shouldn't be too long or too short. Should be moderate, because if it is too long, it means instructions won't be able to be carried out faster. So what all this means is the data cycle path should be optimized to ensure that the CPU keeps up with modern computational demands, as in balancing the speed, the efficiency, and then the power consumption. So now let's look at how the CPU works as a whole. Now the CPU is the brain of the computer, meaning it's responsible for executing all instructions of the computer, meaning the calculations, everything else, processing of data, all that. The CPU is in charge of making sure all that is possible and runs smoothly. So now the CPU is made up of different components. That's the control unit. The control unit directs or allocates the operations of the CPU. And then the ALU, that's the arithmetic logical unit, which is responsible for the calculations and all that. Then the registers. This is the small fast memory locations inside the CPU that temporarily store data, instructions, and results of computations. The cache, buses, and clock, all that is under the CPU. The buses are the pathways the data travels through. The clock provides timing and signals, synchronizing operations in the CPU. Now let's see how we are going to look at how the CPU fetches or receives instructions from the memory. First of the program counter, PC, keeps track of the memory's addresses of the next instruction to be executed, meaning it keeps the memory address of the next instruction to be executed. And now how the CPU fetches instructions. The CPU sends addresses from the PC to the memory via the address bus, and then the memory returns the instruction stored at the address via the data bus and is loaded into the instruction register. That's how the CPU fetches instructions. It sends the PC's address to the memory, and then the memory looks at that address and then sends the data to that address. Now decoding. After the data has been fetched by the CPU to the instruction register, the instruction register now holds the fetch data for the control unit, which reads the instruction in the instruction register, then decodes it with binary representations, that is the zeros and ones. Then the instruction format is typically divided into fields such as the opcode and operands. The opcode specifies the operation, and then the operand specifies the data or the register's location. Now, for the execution of the instructions, the CPU performs the operations specified by the instruction. That is the arithmetic or the logic operations. That is what for the arithmetic and logic operations, the arithmetic logic you need to handle that. That's the calculation, that's in plus or minus, subtraction, all that. That will be done by the array. Then the data transfer is if the instruction involves moving data, the CPU transfers data between memory registers or the input-output devices. The control flow. If the instruction modifies control flow, then the program counter is updated to the specified address, and then storing of results. Now, after the CPU has done all this, the operation is written back to the register or memory location as specified by the instruction and is stored under a new address or different address after all this decoding has been done. Example of the cycle the CPU uses, like so for example, if you enter a command in your computer's calculator like 3 plus 2, 3, let's say, is registered in a register R1 and 2 is registered in a register R2. So now to get R3, the arithmetic logic unit is going to look at the address of R1 and the address of R2. Then it's going to fetch those two data from the memory, do the calculation, and then send you the result as R3, which will also be registered or stored in the memory under a different address. So all in all, this is a simple way of how the CPU works. Thank you.